Hey guys, welcome to yet another video on this channel. And yeah, so sometime back on my Twitter account, if I just go to the posts, so I like wrote this post about Golang version of a thread safe unique IDs generation. So this was a reply to Vivek's post, which is about how do we generate like unique IDs in C++ that is like thread safe. So it uses these atomics to ensure that the shared counter is incremented in a thread safe manner. So I just made a post here and reply, like I reposted this with a code that how we can do this in Golang. And yeah, let's try to do this in Go and see how it actually works. Okay, so I will just create a new project here, Golang snippets. You can find the GitHub repository link in the description below. So I will just do go mod init atomic stuff. Okay, now again we have the same problem that we had in the last video. Go root source. Okay, what we will do is unset Golang snippets echo go root. Oh man, like in every video we have this sort of problem and half of the time goes in fixing it. Go version. Okay, so we are using this Darwin, whatever, we are using this homebrew Go version. Okay, so go mod init what. Okay, what I will do is I will just create this directory atomic stuff. Okay, now if I do echo, oh my god, it is still using. I need to remove this from this fish shell, which I will do later on. So I will just exit this fish shell. Okay, go mod init. So I've just created this module atomic counter and I will just start this thing, open it in Visual Studio Code. Okay, I will create this main.go file, function main fmt.println hello world. Just confirm that this thing is working, so go run main.go and we can see that this is working perfectly fine. So now let's try to have an integer for I int and the value is default, like the default value is 0. And now what we will do is we will spawn like 100 go routines, I less than 100 or I in range 100. So we will just spawn 100 of go routines. I will just take this thing. Okay, I don't think it is needed, so go func I plus plus. We are incrementing this number I, and ideally what it should give us is 100 because we are incrementing it 100 times. In the end, so it should give us the final value of I, which is going to be 100 hopefully. Obviously this won't work for now because we are not waiting for these go routine to finish. So if I just run this program quickly, we got this 94, which is very weird because this thing is not running completely first of all. So what I will do is I will have this wait group, and every time we are spawning a go routine, what we will do is we will add 1 to the wait group, and when this is done we will finish the wait group. After that we will wait for all the go routines to finish. We will wait for all the go routines to finish. So I'm calling this wg.wait, wait group.wait. It will wait for all these go routines to finish. And what is this quick fix? Simplify by using wait group.go. Okay, I can do this thing also. So it will just create a go routine and it will wait. But okay, I prefer to keep it this way because this is familiar to me. So once all the go routines have completed, we are waiting for all of them to complete and then we are showing the value of I. Now if I run this program again, we are still getting 99. Like once in a while we are getting this value 100, but like initially, as you saw, we got this value 99. What is happening here is that this thing is obviously not thread safe. So this thing is not thread safe, and okay, I will just try to run this program some more time. So you can see that we are getting variable numbers, and obviously like what happens is that incrementing is not such a simple operation. So what it does is that it first reads I, and after that it increments I, and after that it writes I back to the variable. So it's a 3-step process. And what happens is that when we do it like this, obviously like when two of the go routines read the value of I, let's say like both of them have read the same value of I, so like after reading the value of I, instead of incrementing, the other go routine also reads the value of I, so both of them read the same value. And because of that, they increment, let's say that both of the go routines read the same value, which is for example 50, and then both of them increment the value to 51 and write it back to the go routine. So like we have two go routines that wrote the value 51 instead of like writing 52. So a simple fix is to use mutex, mu.lock and mu.unlock. So whenever we are reading the value and writing it back, we are just taking a lock, and once we are done incrementing the value, we are unlocking it. So I will just define this variable mutex sync.mutex. Now when I run this program again, you can see that every time I run this program, we will get the same value, which is 100, because now we are taking a lock. So a go routine is taking a lock, then incrementing the value, and then unlocking or releasing the lock. So this is one way of doing this, but if you just go to my tweet, you can see that we are using this sync atomic package. So what it does is that it automatically makes this atomic uint64, which can be incremented using this add function across go routines, and we don't have to keep on taking the lock every time. So what I will do is I will, instead of doing this thing, instead of using mutex, I will be using sync.atomic. It is the package is sync atomic, so it is actually atomic dot int32 and I dot add 1. So I'm just adding 1 to this I, and now I don't have to use any mutex here, so this keeps the code cleaner. And when I think I dot load should be called, which returns the number and error. If error is not nil, then I will just exit this program. Okay, I.load returns only one value. Cool. So we only have to worry about one value, which is what is being returned from this. And obviously, like, so returning an error did not make any sense. It returns the underlying value, the final value that we get. So I will just run this program again, and you can see that we are getting this value 100. So this is it. So like there was there were two options of doing this. One is to use mutex, which makes our code a bit like not buggy, but it makes our code a bit lengthier, and this is a shorter way of writing the same thing. We are using atomic int, which is already thread safe, and it can be used across go routines without worrying about uh, taking the lock and releasing the lock. So this is much better, like readability wise, and this is an equivalent to uh, like our C++ atomic thing. Yeah, so this is the video, and I will see you in the next one with some other go related feature or some system design stuff. So yeah, till then, have a good time.